It all started over 50 years ago with a simple question. What if a computer could make pictures? How could we use them? And what would they look like generations from now?
Hello, folks. I'm Mr. Computer Image.
Welcome in. I hope you're hungry.
This was the showcase demo. It had 2.5 million polygons or so, 2 rays per pixel, a couple of bounces per ray. The demonstration was, frankly, at the time, incredibly beautiful. That was 5 years ago. Now, 5 years later, Racer RTX, 250 million polygons, 100 times more geometry, 10 rays per pixel, about 10 bounces per ray, and using DLSS, infer like 7 out of 8 pixels, computing only 1 out of 8, and as a result, we're able to render this at 4K, scale it up to 4K 30 hertz. Hit it. Not bad for real-time. While we were reinventing computer graphics with artificial intelligence, we were reinventing the GPU altogether for artificial intelligence. The GPU, when I came to see you last time, 5 years ago, most people would say that this is what a GPU looks like. And in fact, this is the GPU that we announced. This is the Turing GPU. But this is what a GPU is today. This GPU is altogether 1 trillion transistors. This GPU has 35,000 parts. It's manufactured by a robot, like an electric car. It weighs 70 pounds, consumes 6,000 watts. And this GPU revolutionized computer science altogether. And 12 years later, after 12 years working on artificial intelligence, something gigantic happened. The generative AI era is upon us. The iPhone moment of AI, if you will, where all of the technologies of artificial intelligence came together in such a way that it is now possible for us to enjoy AI in so many different applications. Thousands of papers in just the last several years have been written about this area of large language models and generative AI. Here are some examples of some amazing things. This is the Adobe Firefly. Adobe Firefly does outpainting. Imagine the space around the image that we never captured. Move AI does mocap from just video. This is on the upper right. You decide which one's real. I'm going with the left. Viscom does sketch to image guided by language prompt. This one's really cool. There are a lot of people who know how to sketch, and from the sketch and some guidance from your language, you could generate something photorealistic and rendered. The future of computer graphics is clearly going to be revolutionized. And this is really cool. Wonder Dynamics, not only is the name of the company cool, but they do pose and lighting detection and replace the actor with a CG character. It just goes on and on and on. The generative AI era has arrived. Well, what's really profound, though, is that when you take a step back and ask yourself, what is the meaning of generative AI? Why is this such a big deal? Why is it changing everything? Well, the reason for that is, first, human is the new programming language. We've democratized computer science. Everybody can be a programmer now because human language, natural language, is the best programming language. And it's the reason why ChatGPT has been so popular. Everybody can program that computer. Large language model is a new computing platform because now the programming language is human, and what you program that computer understands large language models. And generative AI is the new killer app. These three insights has gotten everybody just insanely excited. And because for the very first time, after 15 years or so, a new computing platform has emerged. Like the PC, like the internet, like mobile cloud computing, a new computing platform has emerged. And this new computing platform is going to enable all kinds of new applications, but very differently than the past. This new computing platform benefits every single computing platform before it. For the very first time, this new computing platform not only enables new applications in this new era, but helps every application in the old era. This is the reason why the industry is moving so fast. But one particular area is extremely important, which is the basic scale-out of the cloud. The basic scale-out of the cloud historically was based on off-the-shelf CPUs, x86 CPUs. While general-purpose computing is a horrible way of doing generative AI. And so we created a brand new processor for the era of generative AI. And this is it. This is the Grace Hopper. We announced Grace Hopper, in fact, just only recently, several months ago. And today we're announcing that we're going to give it a boost. We're going to give this processor a boost with the world's fastest memory called HBM3E. The world's fastest memory now connected to Grace Hopper. We're calling it GH200. The chips are in production. It has 4 petaflops of transformer engine processing capability. And now it has 5 terabytes per second of HBM3E performance. So this is the new GH200, based on the architecture, Grace Hopper, and a processor for this new computing era. The CPU now has 144 cores. The GPU has 10 terabytes per second of frame buffer bandwidth. You could take just about any large language model you like and put it into this, and it will inference like crazy. The inference cost of large language models will drop significantly because look how small this computer is. And you could scale this out in the world's data centers. You can connect this with Ethernet, you can connect it with InfiniBand, and of course, there's all kinds of different ways that you can scale it out. This is 2 GPUs, but what if we would like to scale this up into a much, much larger GPU? Run it, please. All right. This is actual size, by the way. This is actual size, and it probably even runs Crisis. The world's largest single GPU. 1 exaflops, 4 petaflops per Grace Hopper, 256 connected by NVLink into one giant system. And so this is a modern GPU. So next time when you order a GPU on Amazon, don't be surprised if this shows up. OK, so that's how you take Grace Hopper and scale it up into, of course, a giant system. Future frontier models will be built this way. And so let me show you this. This is how you would do it. And so now you would have a single Grace Hopper in each one of these nodes. This is the way computing was done in the past. For the last 60 years, ever since the IBM System 360, and for the last 60 years, that's the way we've been doing computing. Well, now, general purpose computing is going to give way to accelerated computing and AI computing. Every single application, every single database, whenever you interact with a computer, you'll likely be first engaging a large language model. That large language model will figure out what is your intention, what is your desire, what are you trying to do given the context, and present the information to you in the best possible way. Well, if you were to have an ISO budget way of processing that workload, it would take, let me just choose a number, $100 million, and $100 million would be a reasonably small data center these days. $100 million would buy you about 8,800 x86 GPUs. It would take about 5 megawatts to operate that, and I normalize the performance into 1x. Using the exact same budget with accelerated computing Grace Hopper, it would consume only 3 megawatts, but your throughput goes up by an order of magnitude. Basically, the energy efficiency, the cost efficiency of accelerated computing for generative AI applications is about 20x. 20x in Moore's law and just the current way of scaling CPUs, that would be a very, very long time. And so this is a giant step up in efficiency and throughput. So this is ISO budget. Let's take a look at this now again, and let's go through ISO workload. Suppose your intention was to provide a service, and that service has so many number of users, and so your workload is fairly well understood, plus or minus. And so with ISO workload, this 1x, $100 million using general purpose computing and using accelerated computing, Grace Hopper, it would only cost $8 million. $8 million and only 260 kilowatts, so 20 times less power and 12 times less cost. This is the reason why accelerated computing is going to be the path forward. And this is the reason why the world's data centers are very quickly transitioning to accelerated computing. And some people say, and you guys might have heard, I don't know who said it, but the more you buy, the more you save. And that's wisdom. Let's talk about a couple of new things. And so today I want to talk about Omniverse and generative AI and how they come together. The first thing that we already established is that graphics and artificial intelligence are inseparable. That graphics needs AI, and AI needs graphics. Graphics needs AI, and AI needs graphics. And so the thing that we could do is we could create a virtual world that is physically simulated, physics simulator, that allows an artificial intelligence to learn how to perceive the environment, using a vision transformer maybe, and to use reinforcement learning to understand the consequences of its physical actions, and learn how to animate and learn how to articulate to achieve a particular goal. And so one mission of a connected artificial intelligence system and a virtual world system that we call Omniverse is so that the future of AI could be physically grounded. The number of applications is really quite exciting because, as we know, the largest industries in the world are heavy industry, and those heavy industries are physics-based, physically based. And so first application is so that AI can learn in a virtual world. The second application, the second reason why AI and computer graphics are inseparable is that AI will help also to create these virtual worlds. Let's take a look at what WPP, the world's largest ad agency, and BYD, the world's largest electric vehicle maker, how they're using Omniverse and generative AI in their work. Play it, please.
WPP is building the next generation of car configurators for automotive giant BYD's Denza luxury brand, powered by Omniverse Cloud and generative AI. OpenUSD, an Omniverse cloud, allows Denza to connect high-fidelity data from industry-leading CAD tools to create a physically accurate, real-time digital twin of its N7. WPP artists can work seamlessly on this model in the same Omniverse cloud environment with their preferred tools from Autodesk, Adobe, and SideFX to deliver the next era of automotive digitalization and immersive experiences. Today's configurators require hundreds of thousands of images to be pre-rendered to represent all possible options and variants. OpenUSD makes it possible for WPP to create a super digital twin of the car that includes all possible variants in one single asset, deployed as a fully interactive 3D configurator on Omniverse Cloud GDN, a network that can stream high-fidelity, real-time 3D experiences to devices in over 100 regions, or used to generate thousands of individual pieces of content that comprise a global marketing campaign. The USD model is placed in a 3D environment that can either be scanned from the real world using LiDAR and virtual production, or created in seconds with generative AI tools from organizations such as Adobe and Shutterstock. This innovative WPP solution for BYD brings generative AI and cloud-rendered real-time 3D together for the first time, powering the next generation of e-commerce.
God, I love that. Everything was rendered in real time. Nothing was pre-rendered. Every single scene that you saw was rendered in real time. Nothing was changed. You literally take the CAD, drag it into Omniverse, you tell an AI, synthesize and generate an environment, and all of a sudden the car appears wherever you like it to be. So this is one example of how generative AI and human designs come together to create these incredible applications. And so how do we do this? Applications, generative AI models are making tremendous breakthroughs. In fact, the Hopper GPU was impossible to design by humans. We needed AIs and generative models to help us find the way to design this thing in such a high-performance way. And so it augments our design engineers. It makes it possible for us to create some of these amazing things at all. And of course, the productivity of the teams go up tremendously. Well, we would like to do this in just about every single industry. Now we just need some powerful machines. We have powerful machines in the cloud, of course. DGX Cloud has many footprints around the world. But wouldn't it be great if you had a powerful machine under your desk? And so today we're announcing our latest generation Lovelace GPU. The most powerful GPU we've ever put into a workstation is now, oh gosh darn it, I just put my fingerprints on there. Can you guys see that? That's not me. Could you? Hey, can I have this cleaned in the future? My bad. Sorry, everybody. My bad. They work so hard. It goes into these amazing workstations, and these amazing workstations packs up to 4 of these GPUs. It packs up to 4 Nvidia RTX 6000s, the most powerful GPUs ever created, and it run real-time ray tracing for Omniverse, as well as train, fine-tune, and inference large language models for generative AI. Incredibly fast, incredibly powerful, and it produces answers in seconds, not minutes in some of the services that are out there. Okay? And so another incredible machine are the servers. And these servers, as you know, getting GPUs in the cloud these days is no easy feat. And now you can buy it. Okay, you could have your company buy it for you and put it in the data center. And there's a whole bunch of these servers, a whole bunch of different configurations. I don't know if you guys could see this. This is a server that has up to 8 of the L40S Ada Lovelace GPUs. And of course, these are not going to be used for frontier models. These are really used for mainstream models today that you can download from Hugging Face, or NVIDIA could work with your company to create. You could use in just about all kinds of applications around your company. And you could fine-tune it with these GPUs. The fine-tuning of a GPT-3 model, okay, so this is GPT-3, 40 billion parameters, takes about 7 hours for about 1 billion tokens. And so 15 hours in a workstation with 4 GPUs, of course, takes less with 8 GPUs. And just in fine-tuning, this is 1.5 times faster than our last generation A100. And so L40S is a really terrific GPU for enterprise scale fine-tuning of mainstream large language models. These amazing new enterprise systems that are in production today. All right, let's change gears and talk about what's going on at SIGGRAPH this year. I'm pretty sure all of you have already heard about OpenUSD. OpenUSD, is a very big deal. OpenUSD is a framework, a universal interchange for creating 3D worlds, for describing, for compositing, for simulating, for collaborating on 3D projects. OpenUSD is going to bring together the world onto one standard 3D interchange and has the opportunity to do for the world and for computing what HTML did for the 2D web. Finally, an industry standard, powerful and extensible 3D interchange that brings the whole world together. A really big deal. Now let's take a look at why it is such a visionary thing that Pixar did. I forget exactly when they invented it, but they open sourced it in 2015. And they've been, of course, using this framework for over a decade, building amazing 3D content. Well, the 3D pipeline is incredibly complicated. You got designers and artists and engineers. They all specialize in some part of the 3D workflow. It could be modeling and texturing, materials, physics simulation, animation, set design, scene composition. There are so many parts and so many different tools. And because the tools are created by different companies and largely incompatible, import and exporting data conversion is just part of the workflow. And because they're incompatible and because there's all this import and exporting, fundamentally, the workflow has to be serialized. It's impossible to parallelize that. And this is one of the reasons why creating these incredible 3D animation movies are so expensive and take so much time. Could you imagine if every single tool was natively compatible with USD? Then as a result, everybody can work in parallel. The interchange and conversion goes away. And instead of a serialized model, you have a parallelized spoken hub model. And so this way of doing work, of course, is incredibly appealing, and it's one of the reasons why the vision of OpenUSD has taken off. It's being adopted in film, architecture, engineering, and construction, manufacturing, and so many different fields of robotics. Well, 5 years ago, we started working with Pixar, and we adopted USD as the foundation of Omniverse. It's not a tool in itself, it's a connector of tools. Okay, so Omniverse is a connector. Well, let's take a look at how the vision of OpenUSD came together. And this is just a fantastic illustration. Starting from the left here, I think this is a Adobe Stager, Houdini. This is a modeling system, Maya, or animation system, modeling system. This is Omniverse, Blender, RenderMan, Pixar's RenderMan, and Unreal Engine from Epic, a game engine. Literally all OpenUSD. One data set ingested into everybody's tools, and it looks basically the same. Everybody's rendering system is a little different, and so the quality of the rendering is a little different from tool to tool, but one data set available and usable by every tool. This is the vision of OpenUSD. So incredibly powerful. Now, Omniverse, as I mentioned before, is not a tool. It's a platform for tools. It's not a tool. It's a platform for tools. Okay, and so we would like to put Omniverse in as many places as possible. There's a whole bunch of different applications. And we showed you earlier how we used AI Workbench to train this model, to fine-tune this model. We started with Llama 2, and we fine-tuned it for USD. And so let's take a look at the video.
For USD developers, building, profiling, and optimizing large 3D scenes can be a very complex process. ChatUSD is an LLM that's fine-tuned with USD functions and Python USD code snippets using Nvidia AI Workbench and the NeMo framework. This generative AI copilot is easily accessed as an Omniverse Cloud API, simplifying your USD development tasks directly in Omniverse. Use ChatUSD for general knowledge, like to understand the geometry properties of your USD schema, or complete previously tedious, repetitive tasks, like generating code to find and replace materials on specific objects, or to instantly expose all variants of a USD print. ChatUSD can also help you build complex scenes. such as scaling a scene and organizing it in a certain way in your USD stage. Build bigger, more complex virtual worlds faster than ever with ChatUSD Generative AI for USD workflows.
ChatUSD. Now everybody can speak USD. And ChatUSD could be a USD teacher, it could be a USD co-pilot, and help you create your virtual world. Okay? Enhance your productivity incredibly. We're super excited about the work that we're doing here. We're so happy that we chose OpenUSD as the foundation of Omniverse and all of the work that we've done to extend it into real time, into physics-based applications. And this is the beginning of a journey that we will finally be able to digitalize, to bring software-driven, artificial intelligence-powered workflows into the world's heavy industries, the $50 trillion worth of industries that are wasting enormous amounts of energy and money and time all the time because it was simply built on technology that wasn't available at the time. And so Omniverse for industrial digitalization. Well, all of this momentum that we've already seen with OpenUSD is about to get turbocharged. Alliance for OpenUSD was announced with Pixar, Apple, Adobe, Autodesk, Nvidia as the founding members. The Alliance's mission is to foster development and standardization of OpenUSD and accelerate its adoption. So whatever momentum we've already enjoyed, the vision that we've already enjoyed, it's about to get kicked into turbocharge. Well, I want to thank all of you for coming today. And remember, accelerated computing and generative AI, the more you buy, the more you save.